Hello and welcome to my Pre-Algebra review series. This video covers Chapter 10, Section 6, titled Surface Area, Pyramids, Cones, and Spheres. By the end of this video, you will have reviewed recent lessons regarding finding the surface areas of pyramids, cones, and spheres. Additionally, you will have reviewed a real-world problem of finding the surface area, of a basketball. Please leave a like if you find this video helpful. Give your classmates a heads up too. It will more than likely help them, and it will certainly help this channel to be seen by more students. If you'd like me to cover any of these topics in greater detail, please leave a comment here in the comment section below. I read them and do my best to address each as time permits. Please subscribe to my channel and ring the bell icon to be notified every time I release a new video. Thank you. So before we get started, let's look at our definition. Slant height. You can use the slant height, it's L, for the height of a face to find the area of lateral faces. If n is the number of lateral triangle faces, you can multiply it. Objective 1, finding surface areas of pyramids. In this review, pyramids are regular pyramids. They have regular polygons for bases and congruent isosceles triangles for lateral faces. See the picture of it here on the right. So we have a polygon for a base, a standard polygon, nothing fancy, and it has in this case it's a quadrilateral, so it has a rectangular shape of some kind, maybe a square. It has triangular faces, lateral faces, and in this case there'd be 4 of them. Okay. You can use the slant height, L, slant height, that's right here, they're showing it, is the L, is the height of the face on the slant, not vertically from the vertex down perpendicular, it's along the face. The height of the face, to find the area of the lateral faces. If n is the number of lateral triangular faces, LA is equal to n times 1/2 BL or 1/2 PL at perimeter times L, the height. Okay, the concept here is, key concepts, surface area of a pyramid. The lateral area of a pyramid is 1/2 the product of the perimeter of the base and the slant height. That's defined by that L term. The surface area of a pyramid is the sum of the lateral areas and the area of the base. So you add up all the lateral faces of the lateral areas, there's 4 triangles in this case, and you add in the base, the area of the base, and you'll have the area of the pyramid. Okay, example 1, finding the surface area of a pyramid. So to find the surface area of a square pyramid, so there's going to be 4 lateral faces, 4 triangles for the lateral faces. So LA is 1/2 PL. Use the formula for a lateral area. So 1/2 times 48 times 16. Well, where do we get the 48? The 48 comes from the fact that there's 4 12s. We're adding them up. 12 plus 12. Plus 12 plus 12. 4 times 12 is 48. That's where the 48 comes to. The 16 comes from right here. They tell us that the slant height of this triangle is 16 centimeters. So P is equal to 4 times 12 and L is equal to 16. The total area is then going to be 384 centimeters square. Find the surface area of the entire figure. So the surface area is the LA, the lateral area, plus the base. There's 1 base. Use the standard formula for surface area. So 384 comes from the lateral area plus 12 squared. 12 times 12 is the area of the base, or the base times the height, if you will, 12 times 12. So that equals 144, and 384 and 144 is 528 centimeters squared. And that's where we answer it right here. The surface area of the pyramid is 528 centimeters squared. Okay, example 1, check your understanding. Descriptive directions. A pyramid has a square base with edges of 20 feet. The slant height is 8 feet. find the surface area. Okay, so the surface area is LA, right? It's LA. L period A period is equal to what? What did we decide it was? It was the surface area is 1/2 P L. That's how they draw that L, that fancy little L there, for the slant height. And when we write that, so LA is equal to 1/2. And what is P? Well, if we draw it, right, then you got these triangles, right? I can't draw them all, but there's triangles all the way around. So this area, these here, it says it's 20 feet. So 20 times P is 4 times 20. 1/2, 4 times 20, times the slant height is 8 feet. Okay? So 4 times 20 is 80. Half of that is 40. Times 8 is 320. So LA is equal to 320 what? Feet squared. Now the SA is equal to LA plus the base, one base. So the LA is 320 plus the base is 20 is the length. 20 times 20, okay, is 20 squared, or 400, if I'm not mistaken. 20 times 20 is 400. And that together will equal 400 and 320 is going to, the SA is going to be equal to 720. What? Feet square. Okay, good. Objective 2, finding surface areas of cones and spheres. 1 second, please. I've got something I've got to look at. Okay, sorry about that. I'm still fighting some throat congestion here. In this review, every cone is a right circular cone with the vertex of the cone directly over the center of the base. So there's no slanting cones, okay? And it says here that the lateral area is 1/2 2 pi r times L, or pi RL. I like the pi RL. It's easier to, you don't have as much to write. So as we see it here, it's the cone is, we have a base. That's the 2 pi r part. That's the circular distance around the circle. And then we're like looking at this triangular part, which is the height, right? But the L is like a slant height. You see how it's in this line here, the height is a slant height. They're showing you right there, slant height. So the lateral area, as we open up this cone, it's like a pie shape, right? It's like a piece of pie with a base. So it says, key concepts, there's 2 of them here. Surface areas of a pyramid. The lateral area of a pyramid is 1/2 the product of the perimeter of the base and the slant height. The surface area of a pyramid is the sum of the lateral area and the area of the base. So the lateral area is 1/2 the perimeter of the base times the slant height. And the SA, the surface area, is the lateral area plus the base area. And the next key concept, and you see that's right here, you see it's L is the slant height. You have, here's the base, and there's R on the base, so we can find everything we need right here. We know the distance around the circle, that's this P. L is the slant height, and it's 1/2. Okay, and then the base is just pi r squared for the area of the base. Surface area of a sphere, the surface area of a sphere of radius r is 4 pi r squared. It's just like the area of a circle times 4. In fact, that's exactly what it is. The area of the circle times 4. Just remember that. The area of a sphere is made up of the area of 4 circles with the same same radius, 4 of them. Okay? Okay, example 2, finding the surface area of a cone. The lateral area is pi RL. That's using the formula for lateral area, pi RL. And for pi RL, we have pi, which is 3.14. R, the radius, is 4, and 10 is L. The 10 is the slant height. When we multiply that out, we get 125.6, and I can put in the centimeters squared, so it's part of the answer. So now the surface area is the lateral area plus the base, and it's 125.6 plus pi r squared. Pi r squared is the area of a circle. So 125.6 plus 50, because it's 4 squared is 16. 16 times 3.14 is 50.24. 50.24. Added together is 175.84 centimeters squared. And for the answer down below here, it says the surface area of the cone is about 76 centimeters squared. Example 2, check your understanding. A cone has a slant height of 39 feet and a radius of 7 feet. Find the surface area. Your job. Go ahead and give it a shot. When you get back, we'll do it together. Okay, I assume you've done that, so let's give it a try. So we're going to do a cone and see if we can look at this. The cone, I'll draw it over here. It's a cone, right? I'll just do this, and then I'll draw a base around. How's that? That's a pretty good cone. And it says the slant height is 39 feet, and the radius is 7 feet. So what do we get? The lateral area is pi RL is equal to pi RL. Okay? And if we extend that out, the lateral area then is equal to 3.14 times the radius of 7 feet times L, 39 feet. Okay, and then what does that come out to? The lateral area is, well, we have the calculator. Let's get the calculator. I'll stop the video and get a calculator here. So when I did the math on that, it comes out to the equals 857.22, and this is in feet. I think it's feet square. And then from here we're going to do the SA, which is the LA plus the base. And the LA is, we said, is 857.22 cm. Oh, back up. I'm getting cm's on the brain here. Feet square, and this is the SA, plus pi r squared, 3.14 times r, which is 7 feet squared. So that equals 857.22 feet squared plus 3.14 times 7 squared is 49, and that equals 857.22 feet squared plus 153.86 feet squared. And when you add them all together, the SA is equal to 11. What is it? It's 1,011 feet square. 1011 feet square. Right there. That's your answer. Okay? And the reason I stopped to do the calculator and not do it on is because these videos are long enough and you're sitting here watching them. I don't want to take any more time than we have to. I could take the time to do it on the screen, but I think to your benefit, I'll just get the math done and it'll save a little bit of watching time for you on your side. Example 3, it's a real world problem to solve. Calculate the surface area of the basketball at the right. Well, the surface area is just that. There is no lateral area. It's all surface of a sphere. So the SA surface is 4 pi r squared. And what you see there is the pi r squared right here, pi r squared. That's the area of a circle. And it's 4 times the area of a circle. So use the formula for the surface area, which you get 4 times pi, 3.14, times r squared, which comes 5 is the radius. So 4 times 3.14 times 25. 5 times 5 is 25. And if you multiply that out, 4 times 25 is 100. So 3.14 times 100 is 314 inches square. The surface area of the basketball is about 314 inches square. And why do we say about? Because remember, we're using pi. And once you use the value for pi and not just the term pi, you have to say about. Okay? A sphere has the same surface area as 4 circles with the same radius. And I think I've mentioned that before, and that's kind of interesting. Example 3, check your understanding. A sphere has a radius of 6 centimeters. Find the surface area. Well, the surface area, S dot A, is equal to, and we know what it is, right? It's 4 times pi r squared. And we've known it's 6 centimeters is the radius. So the SA is equal to 4 times pi, which is 3.14, times 6 squared. SA is equal to 4 times, let's see if that comes out, how this turns out, 14 times 36. Well, nothing's going to come out easy on this. So 4 times 36 is, 4 times 30 is 120. 4 times 6 is 24, 140, 120, 144. Right? No, 4 times 36, 120, and 4 times 6 is 24. Yeah, it's 144. And it's equal to 144 times pi, 3.14. And that's the SA. And when you carry that out, it ends up being the SA is equal to 400, it's approximately equal to 452 centimeters square. 452 centimeters square. That's the surface area of that sphere. Okay?